So in this video we're going to go over how to graph a linear function that's in slope-intercept form by finding its intercepts, its x and y intercepts. And we're going to do this in the case where we get integer valued intercepts, or in other words where the intercepts turn out to be nice. So here's the function that I have, and my instructions are to find the intercepts of f of x and use them to graph f of x. And what we want to remember is that the intercepts occur where our graph crosses the y and the x axes. So in particular, the y-intercept is right here. This is the y-intercept. And at the y-intercept, what's key to remember is that the x-coordinate is going to be 0, which means we need to determine f of 0 in order to find the y-intercept. So for the y-intercept, what we have to remember is we're going to plug in 0 for x, and then we need to evaluate the function at 0 to find that intercept. So we'll take our function f of 0, here's f of x, so everywhere we see an x, we replace it with 0, so we get negative 1/2 times 0 plus 2. But negative 1/2 times 0 is 0, and 0 plus 2 is 2. So when we input 0 into the function, the output f of 0 is a 2, so we get the ordered pair, input 0, output 2, and this is the y-intercept. Again, the y-intercept, the x-coordinate, will always be 0. For the x-intercept, which is right here, here's our x-intercept. What we want to remember is that we don't know the input x. So we don't know what x is, but we know that the output is going to be 0. And we want to remember that we have input, output pairs. So this tells us that the output, f of x, needs to be equal to 0 when we're at the x-intercept. So if we're looking for the x-intercept, what we want to recognize is that 0 will need to equal f of x. The output will need to be a 0 from our function. So we know what f of x is. F of x is just this function machine right here. So we replace that with negative 1/2 x plus 2, and this needs to equal 0, and we just solve this for x. So this is just right now I have a linear equation in one variable, so I'd subtract 2 from both sides and then multiply both sides by negative 2, which will give me 4 equals x. So for my x-intercept, I see that when I plug in 4, the function output is going to be 0. So there's a couple ways now that we can graph this. We have the x and the y-intercept. So there's really two choices. And one of them I might do more if I had a ruler. So one way to do it is to say, hey, I'm going to need to go out 4 units on the x-axis. I'm going to put tick marks in. 1, 2, 3, 4. And then I'm going to plot the point 4, 0, which is the x-intercept. I'm going to go ahead and plot that point. So here's the point 4, 0. And then I'm going to scale the vertical axis, or the f of x axis or y-axis, the same way. So tick marks about the same, 1, 2, and then plot the other intercept, which is at input 0, output 2, and then draw the line through those 2 points. The downside to this option is if I don't have a ruler, I'm trying to connect the dots, and I think you tend to get a little bit sloppier of a graph because you're trying to connect the dots. But that would work. I would really want to do it this way. I would really want to have a ruler so I could make nice straight axes, a nice straight line. Otherwise, when I try to connect the dots, I, as a poor artist, always get kind of crooked lines. Let's finish this guy out and then look at a different way of doing this same graph. So to finish this out and get full credit on an exam, I have my X and my Y axes. They need to have arrows on them. I need to make sure I have arrows on my function. I need to make sure that I've labeled the intercepts with their ordered pairs. And does that look like I've got everything done? I don't have the X label on the X-axis, so I've labeled both axes, arrows on the number lines or the axes, arrows on the function, intercepts labeled. So that would be one possibility. However, I think that when you're hand graphing, you usually don't need finely detailed tick marks on your axes. I think the idea of a quick hand graph is to get a sense of what the function looks like. So if I were doing this, I wouldn't do tick marks first and then plot my points. What I would do is lay out my axes as best I can. And then what I would do is get an idea for where these points would go. So 4, 0, maybe that's a point somewhere over here. And I recognize that if I plot the point 0, 2, this height 2 is going to need to be about half the height of this distance of 4 units here. So I know that when I draw my line, wherever I intersect this axis, I need to land about twice as far out on the x-axis to make a graph that's reasonably to scale. So what I would do is just draw, I would have an idea of how I wanted to draw it, and I would just draw a line in. And it doesn't have to be perfect, but because I just drew a line and I didn't try to connect the dots, I wound up getting a line that was a lot straighter. And now label the intercepts. So this intercept here has to be the 0, 2, the Y-intercept value from over here. And this is going to be input 4, output 0. That's the X-intercept coming from here. See, I didn't need to do tick marks. I draw in a rough picture, then I label, and I think this is an easier way to do it. And I think as you move forward and you're working with increasingly complex models that you need to get quick sketches of, and when you move into trigonometry and you have to do sketching of sinusoidal graphs, that this technique is going to be better than trying to do tick marks and fit things. So to get full credit, I need to finish this out. This is my f of x, or my y-axis. This is my x-axis. Let's double check and make sure we have everything we need. I have both of my intercepts labeled with their ordered pairs. I have arrows on my axes. I have arrows on my linear function. So this looks like a graph that would get full credit on an exam.